welcome Mr. Shinto Joseph, Director, Southeast Asia Operations LDRA, for the first technical presentation of the day. An entrepreneur by heart, Mr. Joseph has been involved with embedded design for over 2 decades. He has previously worked with SPA Computers, Dharma Systems, Trident Infosol, and as I said, is currently associated with LDRA. Mr. Joseph, all over to you now.
Thank you. Am I audible?
Yes.
Yeah, I was listening to the discussion, especially the questions, and a lot of questions I can see coming from a safety perspective. I will add further on the top of that with the topic on functional safety for two-wheelers. I think my screen is visible.
Yes, Shinto, it is visible.
Thank you. So this is what I want to discuss in the next 15 minutes. What is functional safety? Because people get confused nowadays, what this whole thing is about, and especially when people mix it with technical terminologies. I would try my level best to explain this whole concept, how a common man can understand. Then we'll go to the standard ISO 26262 and practical implementation challenges we'll discuss, especially in the Indian context. So this is a modern bike, right? It's all about electronics and software. I call it software-defined bikes. There's a concept called software-defined cars. This is an extension of further, when we put more and more electronics and software into modern bikes, the definition of bike completely changes. And cars also, same thing you are seeing, right? Your driving experience, and it doesn't stop there. It also brings in additional challenges from a safety and security perspective. During the presentations, I heard people talking about cybersecurity. I am seeing cybersecurity from a bike internally, how people could hack your bike and take control of your bike, even if you're sitting on the top of the bike. How the failure of a subsystem in your bike can lead to catastrophic accidents. Now, for that, I need to take you to the next slide to explain the traditional definition versus the modern approach. Traditionally, automotive industry is known for something called quality. You've heard of, SPIs. How do we reduce the parts per million failures, Six Sigma concepts. The quality models evolved, matured over a period. It is still doing very well. And that is the foundation of every quality product today now coming into the market. But if you look at modern electronics-based systems, it's failing, and that failure leads to accidents and deaths. That gave further studies to understand why that is happening. It is a quality product, but still failures are happening, accidents are happening, deaths are happening. The quality concepts are not helping us. So that gave birth to a concept called risk-based thinking. If a subsystem fails, if an electronic unit, an ECU, I call it electronic control unit, which is a combination of a couple of electronic components, a chipset, and some software inside. That is a typical ECU is all about. And if ECU level failure happens, based on the impact of the failure, whether it leads to a catastrophic failure, means serious accident, somebody dying, or if that is leading to a minor accident, whether people are not going to die. So you have different levels based on which the impact of a failure could be assessed, from a severe to less severe to not so severe kind of levels. So in cars, we normally have nowadays called 4 levels. We call it automotive safety integrity levels, ASILs. Similar to that, in bikes, we have MSILs, motorcycles, you know, safety integrity levels. It has come up. So further, when I go, this whole concept of risk-based thinking is the foundation behind modern safety and security principles in cars and bikes. And this talks about what is running inside the car and what is running inside the bikes. The other aspects like the cloud-based communication systems, wireless-based operations, or GPS, whatever is happening outside is different. I'm talking about what is there inside. Now, if I go further, as I told you, these systems are basically a combination of a semiconductor chip and software running around that. And the more the complexity of modern bikes, the more the lines of code running inside. And to the extent you can say the modern cars, people are talking about more lines of code of running in a car than an Airbus 380. 380 is my customer, so we have some idea what is running inside. So we do have a lot of bike manufacturers also nowadays of late became my customer, wherein they traditionally they never used to bother about these aspects, but now they know if something goes wrong with the software code running inside, that can lead to serious accidents, thereby deaths. So a typical life cycle, this is a standard cycle. You can make it further complicated by putting into a V model, which normally people use in the automotive industry. So it starts with your requirements. What is that you're going to do, including safety requirements, security requirements, you list it down. Then we have an overall architectural design, how ECU you're going to design. And you start developing your code. Finally, you test it, you do an integration with the rest of the subsystems. That's way, any electronics-based systems are designed, developed, and tested. Finally, it goes for safety testing, safety audits. It goes for regulatory approvals and the standard process for all the products. We will revisit that part also, how normally that works in an industry like automotive industry. Now, this is a technical definition of functional safety. Why, looking at this definition, it doesn't mean anything for a common man, right? Why people don't understand this subject, it's also because of people define these things a bit complex. Now, to make it simple, I will take you to an overall vehicle safety or overall bike safety. You can do a crash test. So you call it overall bike safety or overall car safety, right? Normally, when you do a crash test, those kind of things, that's what people look at it. But I spoke about, the impact of failures at the component level, right? Each subsystem when it fails. So if I break it down to each subsystem and based on the impact those failures, what level of severity for those failures are having at the subsystem level, if I am able to make assessment for a safety parameter, that's where the definition of functional safety comes in. So at the ABS, at the traction control, whatever you are doing, even a tire pressure monitoring system, every subsystem level, if I go deeper into that, I first do an assessment of what is the impact of if this fails, right? So that decides my safety integrity level, which level I need to put it. Once I define, after doing a risk assessment process, once I define which level each of the subsystems should be coming in, then I start my design based on that, because that includes the reliability parameters, because they should have a fail-safe operation also. In case something goes fail also, the other channel should take over, right? Because those are the subsystems which are at the highest safety levels. And bikes, I will tell you, it is further complicated, unlike the car, because bike is an unstable device, right? Car is sitting on 4 wheels. So we will see that part also. There is a slight definition difference when it comes to motorcycles. This is the world of functional safety. It brings in liability clauses. It brings in definition of the organizational level, techniques, practices, technologies. It's a combination. It's a complex world. But if you go minute aspect of the thing, it is not so complex. But underlying principle, you just look at the bottom line. It's all derived from quality principles. Your quality management system, QMS plays a major role. That's where we start. Without a QMS, sorry, you're not going to think about functional safety, right? And let me take you to the next aspect where I was asked to talk about ISO 26262, which is basically the functional safety standard. The first version of functional safety, ISO 26262 standard, as a standard came in 2011. 2018 was the next revision. To be frank, even today, 26262 is not a legal document for which you will get penalized if you don't follow it, right? There is a big difference. It is not a legal document which you will be getting penalized if you don't follow it. Unlike the later version, the cybersecurity standard, which is the 21434, which is the base of the European WP29, which is the cybersecurity regulatory standard and the regulation associated with that. It is a legal document. July 23 onwards, it is legal. You can't sell anything in Europe without that. So you will see security of your car, security of bike taking a precedence over safety, from a legal angle. But believe me, it will be a very good valid document when there is a court case tomorrow, right? Tomorrow, when there's a court case, some repeated accident happens, your bikes, as a manufacturer, you will be pulled up. And that time, if you have a functional safety compliance, your documents ready, yes, you are on the safe side of the game. And the latest trend which I'm seeing is, even in the Indian context, I can see Indian manufacturers giving more importance to functional safety concepts. You won't believe. I work with the global OEMs and Indian OEMs and the Taiwan vendors. I am seeing last 3 years, there is a terrific effort, a sincere effort by the Indian OEMs to improve the vehicle safety, which is a good sign that in cars also, I'm seeing the Indian cars many times performing better on functional safety compared to a foreign car produced in India. So it's a reality. And that is driven by customers. Customers prefer to have safe bikes on the road, safe cars on the road. This is the ISO 262 standard document. Nothing to worry. It has got total 12 parts. Look at the left middle portion. That part 12 is what is actually talking about the motorcycle version for ISO 26262. ISO 26262 covers all kind of road vehicles, but there is a specific part for bikes. The reason, bikes are more prone for accidents. So there are some changes. What is exactly that? We'll come to that part. We do have a part 11, very specifically talking about semiconductors, because semiconductors play a major role in modern automotive systems. So if you are into an semiconductor development company, if you are developing something, if you have a vendor who is supplying a semiconductor, and if you want to comply to ISO 26262, ask him for evidences that they are complying to it. Many people tell that, we have ISO 26262 compliance, but ask for evidence, because that depends on your final customer or final regulator. If they're asking for regulatory documents, make sure that your vendors are giving you that. If the vendors are not providing, finally, ownership of liability lies with you, right? So we are talking about a shared liability. Everybody in the supply chain should be equally or proportionately. As a tool vendor, LDRI is also liable, right? We are also liable for our part. So where customers ask us to share the liability part, everybody has got a role to play. So part 12 is all about, motorcycle version of 26262, where it is clearly mentioned what you should be doing, what you should not be doing. Look at this side. The motorcycle safety integrity levels are defined based on the severity of accidents, exposure, and controllability. How far you are able to control. There are certain things beyond your control. There are certain things you can control. Now, there is a slight difference between these integrity levels used in the cars and the bikes. But as I told you, bikes are more prone for accident because it's an unstable device. It runs on 2 wheelers. The other one is on 4-wheel. So a level which is typically a level, A to B, C, D level we're talking about, right? The base is all about quality management, no doubt on that. Both cars and bikes follow the same principles. You need to have a base level as the quality management system. Without quality management system, no safety. It's very clear that, and finally, the difference is a level A in a consideration which we give in car is treated as a level B in a bike. That means bikes are more prone for accidents, so they put it to the slightly on a higher risk level. So going further, as an implementation level, this is what happens. We have the 26262 framework going on one side, where we have, as I told you, the risk assessment followed by its implementation. Right side is basically the security, corresponding level where security functions are getting implemented from a defensive perspective. This is where we are talking about your bikes are made safe and secure by design, right? Now, going further from here, the challenges which I see is small on the entire ecosystem. The government has got a role to play. Standard bodies in India, BAS has got a role to play. Regulators like ARA and other organizations has to role to play. If you are a vendor in the global supply chain, by default, I suggest you to start following it without 26262 compliance document. Sorry, you're not going to be part of a global supply chain, right? I would recommend we have expertise at the academia, at the policy level, making regulatory level, at the certification, and make that available happen in our country. Without this making it happen in our country, it is not going to happen. We have a lot of test facilities available. Good. Along with that, we could add these things also. So it's a integral thing. You can't have safety security separately. It is tied up, two sides of the same coin. The bike is hacked while you are driving. There's no safety for that bike, right? There is, even you are going to have artificial intelligence, AI layers. That's where Industry 5.0 principles comes into your bike, making it more inbuilt. What we do as a company, we provide the right tools to qualify your code safe and secure. We also provide a whole lot of things like, we work with universities, skilling agencies, making sure that these skills are made available in this country. Thank you. Please park your questions. In case I don't get time, you can even reach out to me through LinkedIn or somewhere. We will be able to answer your questions. Thank you.
Thank you, Mr. Joseph, for sharing those wonderful insights with us. At this stage, I would like to remind everyone that if you have any questions for our honorable speakers, please send them to us by using the Q&A box located at the bottom of your screens, and we will try to get them answered at the end of the presentations. Now, I would like to welcome Mr. Thalavi Venkatesan, Head of Sales and Key Account Management, Continental Automotive India. Mr. Venkatesan has been with Continental for over 15 years now and has been helping the organization in changing the way the world uses mobility mediums while making sure the same stays safe, smart, sustainable, and most importantly, accessible to all. Mr. Venkatesan, all over to you.
Thanks, Mukul. And also, I would say warm greetings, and also thanks for having me here, and also the Pangshu and the complete Mobility Outlook team. I share my screen. Please let me know you're able to see that.
Yes, it's visible now.
All right.
Coming up.
You're able to see my full screen mode, I guess, right?
Yes.
All right. All right. So I'll talk about more on the two-wheeler side, actually, regarding this, what currently we have from the technology side, from the Continental side. And maybe for that, I think I also give a little bit of a background and where are we on this topics on what we are working on, these technologies. Yeah. So, second. Are you able to see my second slide? I don't know. Maybe it's not still.
It's the, we just see the first slide. There's not.
Right. Okay. So basically, what we talk about here, I think is as we all know, every, you can say the Indian has a different reason to have a two-wheeler, and India is actually one of the biggest two-wheeler market, definitely. And also, as we talk about, you can see the numbers are growing. We talked about 20 million numbers, what we reached at some point of time, and maybe at later stages, we talk about a huge number of two-wheelers. As Prashant was also talking about in the beginning, it's our responsibility to have this sort of a safety technologies, so that I think the whole fatalities can be reduced, and this actually have a contribution, actually what we could do from our side. So you can see here what what basically what we have is a different sort of requirement for the Indian market, quite diverse. from maybe for commute to sports to whatsoever the requirement. But actually currently what we need to, it's our responsibility as a company and also with the OEMs together to bring in the safety technology so that I think we actually contribute also from the responsibility wise as well as also to reduce the overall fatalities. Yeah. So then I think we are talking about the households and the investments, what's happening in India. I don't need to talk about here, actually, like it's more towards, can say, when the overall technology is actually getting better, OEMs are also now trying to bring in different innovative parts so that I think each and every stage, the requirements are changing, but in such a way like we also improve the products as well as the safety aspects on each of the vehicles together. And specifically when it comes to two-wheeler, I think it's very important, like we talked about that, actually, like it's a quite can say unstable, and also we need to have some special reasons to have this sort of technologies. And also as we use in different terrains, starting from cities to maybe some tier 1, tier 2 cities, and the requirements are completely different from that point of view. So now actually currently, you see that what currently in the two-wheeler area, the current technologies what we are in, I'm talking about from the safety aspects here. Mainly we are talking about the anti-lock braking system and also the wheel speed sensor. These are the current, from the braking point of view, actually currently, which is being introduced. Of course, there are a lot of other technologies which are there in different aspects, what Dr. Jora mentioned, but I hear clearly my emphasis actually mainly talking about on the safety side, on the braking system side. So here I think currently the two important the wheel speed sensor is actually the one what we use for detecting the wheel speed and also using it for the input for the ABS for some of the actions which we'll talk about maybe later in the detailed presentations. But currently this is a scenario. But what's happening is currently this is where we are, and future is actually something different. What we say here is like, clearly like it's not only about this wheel speed sensor, also on the braking system side, there are some more things what getting introduced, like this optimized curve braking, which is also very important. And also like we briefly touched about, maybe in the beginning, both Prashant and also Dr. Jora mentioned about that regarding this ADAS technologies, maybe or assisted technologies which are coming into picture. For that, what you see here is the radar sensor, which actually what will be part of the system in future, and also the surround view camera, which also will be part of the system, which we are talking about. And also you can see the short range radar to detect again certain objects which are necessary. And also like for the TPMS, which is tire pressure monitoring system, to introduce that actually to, you can say, for different scenarios which can be used as a safety functions. And this ABS, we'll also talk about, you will see more and more, maybe, what sort of functions can be introduced, which also I will cover in my presentation. So these are the, I think, typically when we know for ABS, clearly we talk about it's for basically maneuvering the vehicle in such a way when the hard braking is done. So we don't want the wheels to be locked up in such a way so that I think the driver still can actually steer the vehicle. And this is an important thing. But on top of it, actually what could be added is actually what you see here. So optimized curve braking is actually something where, which is added safety feature, because, in a curves when actually you're braking, so in such a way, again, there is a maneuvers actually which can be done from the ABS module, so that I think it can actually play with the torque in such a way that the overall slip can be, optimized, so that I think even in the optimized curves, the braking can be done in an optimized way. So this is called as optimized curve braking. And of course, there are some different drive modes which actually we can introduce, like traction controls, like which actually can also talk about in a different way how this can be demonstrated. I think you can go into maybe YouTube and also we clearly see that I think with and without traction control, how the vehicle can be driven in a different mu conditions. And it's very important to have this sort of a function to add it on the function safety side. And also like this connected infotainment, this is where actually we say like more importantly, a lot of enhancement can be indicated through this infotainment devices. And this also can be, since we are talking about all connected devices, including telematics, all put together, this also can be indicated to the driver, so that I think he gives a lot of pre-information, and also like during the drive also you can get a lot of information which actually you could see without not disturbing his sort of awareness to the whole environment. This also is very important, so that I think we can build a different sort of business cases actually. Or I would say, then we're talking about intelligent headlight assist, which is very useful during the night drives actually when we talk about. So typically, you can change the curve and also the way how between the high beam and low beam, and also the optimization how it can be done. This also, it's one of the function possible. And similarly, certain things like this traffic signal assist, and then forward collision warning and emergency brake assist, which all come in along with the assisted features, which actually I'll talk about more on this blind spot and lane change assistant and so on and so on. But very important is like these are the functions possible when introducing maybe a sort of a ABS plus radar plus camera. And then typically it doesn't need to be a full-fledged, maybe a different ECU itself, but can be smart cameras. And maybe first to start with, it can be a sort of an indication to the driver, and maybe it can go to the next step of even controlling and maybe also even assisting. So currently what we have in our portfolio is sort of this 3 products, what you see here. This is called Minimap, MK100 Map, and also MK100 Minimap EVO. The first system, actually, what you see here is the most optimized for the value-driven system, what we call. Basically, like it's more towards a single-channel ABS. So when also like our important, I would say the research currently, what we are trying to do is like, how do we make it more affordable, so that I think it also can be used on a maybe less than 125cc and bikes also, so that I think the affordability becomes a very important feature there. But here, I think it does the basic ABS functions. And also clearly, what you can say do is actually the rear lift protection, which also I'll explain, talk about that maybe later. But more importantly, these are the specific things actually which is introduced as a first step to the Indian market, which actually you could see a lot of improvement. And also you can see all the OEMs today are using one or the other sort of ABS system there. And it's already mandatory, as you're all aware, like 125cc and above. And some of the OEMs are even talking about introducing that in the lower segment of the market, which you will see very soon. And the second topic is actually on this MK100 map, which is the 2-channel ABS. There again, you can actually add some more functions. And also I would talk about that maybe in the coming slides, what are the other functions which actually we can do that with that. Here, I think there's an integrated, inertial sensor is actually included. So that thing you can actually really measure it, and also the ECU can actually take the functions appropriately. And it's an additional features what actually we can introduce. And the third one is actually the MK100 Minimap actually EVO, where there is a thing called, where we are introducing this POA sensor, which is also like where specifically we are talking about different ways of introducing again the inertial things and how we can control on the vehicle by using the maneuvers of the ABS motor, and also regulating the enhancements, how the behavior between the braking between the torque and also the slip versus the friction. I think that the basic principle actually how do we act. And also like this also enhances again to introduce different modes, which actually will be helpful. I'll explain about the modes now, actually what we are actually talking about here. What you see here is actually what I mentioned is actually about the first one, the Minimap redesign, where we are talking about which is already in the market. And then the Minimap, which actually is actually again more affordable, how we can introduce that. And then the latest 3-4 chapters actually are the columns. What you see here is the functions actually we can introduce by each of the, we can say, from the different modules. So here also like very recently we launched this MK100 map POA. It's actually where you can talk about pitch, yaw, and acceleration can be measured using that particular sensor. By this again, the controls of the algorithms can be optimized in such a way like you can get it into more safety regions actually. So this is first time introduced, and maybe India will come a bit later, but already in the European bikes, this sort of functions are being talked about and will be introduced soon. So maybe I'll explain a little bit about this, the functions, what you see here on the top, this rear lift-off protection. This again is actually like where you are actually having a heavy braking, and also when you are actually driving on a high mu area. And at the time, just to have this sort of a lift protection or the rear lift to be protected, again, what we do is actually the overall torque levels can be controlled in such a way, and maybe a small minute level of maybe microseconds of I would say milliseconds of a lag which actually can be created, so that I think the rear lift can be also protected. Similarly, like you see this motorcycle hold and go, it's like a start stop function, like in when you don't, maybe when there is a need of actually like a start stop enabled, and you can also talk about this motorcycle hold and go, means like you hold, you stop it. It can also couple with the other issues in such a way, like the engines can be, the engine can be cut off in such a way, but still you hold the vehicle by braking, not physically. So the ABS function can hold the vehicle. And then the traction control systems, which actually I mentioned. So means like here we talk about, as I said, different new conditions. Actually, when you drive, really this function becomes, sort of a safety mandatory thing to be used, and it gives a lot of, I would say, confidence to the driver to drive in different scenarios. Of course, the optimized curve braking I already explained, and then the deflation detection system. It's actually nothing but using a TPMS, a tire pressure monitoring system. You clearly see that based on the how the tires inflation actually is behaving. Depending on that, again, there is some a lag which can be detected by the wheel speed sensor, by which you can also do some maneuvers so that I think your overall braking systems can be controlled. Of course, then the brake slide assist and few things which also is part of the system where actually you can do this sort of a thing. So what currently in India we are working with this is actually this sort of a modules, so that I think we can actually introduce into different bikes starting from 125cc and below and 125cc and above with a different module, so that I think depending on the OEM requirements, the safety is actually part of it. So our main motivation is like, we don't compromise, at least the safety feature should be part of that, so that in one or the other way, depending on the customer requirement and also depending on the OEM requirement, these functions are getting introduced into the vehicle. So now actually we'll go slightly into that, you can say the assisted functions, which actually can be introduced step by step. This is actually the one of the topic where we are talking about is a short range radar here. This is actually, it's more, when you have to detect certain, a vehicle which is coming behind you and also on the blind spot, a short range radar actually can detect that and give a certain warning to the driver. It can do some functions later, but I think currently we are now talking about at least giving some sort of a indication to the driver in different ways. There are different ways to do that, but actually it's more towards how to do that, an indication, so that I think the driver is fully confident of when he's driving on a highway, or when he's actually not detecting a vehicle coming behind him, or a complete blind spot which is actually not visible to him. This sort of a short range radar can give a more comfort to him, so that I think he can drive with more, with more confidence, and also on the safety side. Of course, then we are talking about this adaptive cruise control. It's more of a comfort function. So you can say like, because you have a radar and maybe possibility, using this different functions, what we have currently, it's possible that I think we can actually detect the distance and also follow a vehicle or maybe a object, depending on how the driver wants to do that. This also like it gives a comfort function, so that I think it's actually like also it does in a different way, and also measures the stopping distance between the object and the driver in a different maneuvers. Actually, it can be used. And again, this is also like an adapt function. It's a safe. I would say when driver is actually can be more relaxed, and as a comfort function, he can drive on the highways. Then we talk about this emergency brake assist and forward collision warning. Here it's a very important feature. Actually, like again, we are talking about whether these functions can be introduced in India. But currently, like we are doing a lot of testing, to really make sure that these functions are becoming more robust, and also detection is actually getting more and more robust. That is the main important thing, because as you know, for any of these functions, which is more important is the detection of the objects in such a way, so that I think we don't end up in a false detections, or maybe we don't end up in maybe a detection which has to happen, which we don't detect it. So these are the things which actually currently we are working on. And as an emergency brake assist, it's very similar to what's being used on a passenger car also here. But here, I think it's also very important as a two-wheeler. It's not easy to introduce as such like a passenger car. Here, actually, like we have to clearly see that we have to really connect and also understand the braking distance. And if the driver is not noticing, we give a small, a little bit of a, maybe braking there, and see if the driver is not noticing anything. Then we do that function, so that I think it can be the accidents what actually can be avoided. It's also a very important feature which will be quite useful. Of course, we need to do a lot of functions detections, and so that I think it can be used in non-highways. In a city, it's maybe quite difficult to currently in the current system. It's quite difficult to use, but this sort of things actually has to be tested and also proven in a long range actually. Yeah. Then we are talking about the cameras. Where actually we are talking about the traffic sign assist. This actually can do a lot of other things like we can detect basically like what is the traffic, and also with this we can do a little bit of sign recognition, and then also take appropriate action and indicate the driver. This also I also like can be coupled with some sort of a e-horizon, which I'll talk about maybe in the next slide or so, where we say like clearly like this important feature comes into detection of overall where the vehicle can be driven, and also predicting the by the cloud connectivity. Actually, we can also see the driver path and also predict the best economical way and so on. Yeah. So then the intelligent headlight assist, which I already talked about, clearly it's one of the high beam and switching off when between high beam and low beam, and also like a glare-free high beam can be also be used, so that I think this is also one of the function which is required in the night, so that I think the driver can also be on a safety side, drive the vehicle. Of course, I think we talked about the connectivity part, which include telematics, the HMI, the wearable devices, and all these things can be all connected. And with this also, like when it comes to cloud connectivity, we can also get the signals from the infrastructure. Maybe in India, it's some steps away, even for the passenger cars. Maybe it'll come a little bit later. But I think more importantly, as a safety functions, as a concepts, it's not available. Means like you get the infrastructure functions, like the signals and everything from, say, for example, your signals, your traffic from the city, and so on, through the infrastructure way, to the telematics and connectivity, to the your maybe the telematic control units, and then also you process it and then takes the optimum way, or maybe a better route, better CO2, also like optimization there, but also at the same time on the you can also indicate a lot of things in the HMI interface, so that I think this can be also always seen as an indication to the driver, so that I think he can avoid this sort of maybe the roads and so on and so on. So similarly, then I think we are talking about this e-horizon, which actually I just mentioned. I know it's actually a cloud-based service. Very clearly, like talking about getting the infrastructure information to the vehicle, to the driver, and so that he can act and maybe do also choose the day what he wants, and also maybe how we can do that. But it's actually done. Currently, it's possible that we have a demonstration to this continental cloud. But I would say these steps will come in India maybe as the best steps. Yeah. Then I would, to conclude from my side, actually like what we are talking about, I think I just talked about more towards the ABS functions, and also the evaluation of this ABS functions. To that, I think what we can introduce as a safety technologies in different ways, and also the assisted functions, which also can help the driver by avoiding this, to avoid such accidents, and also as a from the cloud connectivity, and also from the e-horizon, and also the HMI interface, how actually driver can get more connected. So these are the three areas currently from Conti we are working on, and of course we are trying to see actually like how this features can be brought into India with more affordable, I would say, way. It's a value-driven market, and of course it has to fit into the lower segment of the vehicle to the higher segment of the vehicle, and that's what actually currently we are working on. And of course, our Vision Zero is actually like completely avoiding all the accidents in such a way that I think how we can really contribute to the society, and also make sure that I think we create this awareness among the users